Hello Candles, welcome to Candela Learnings. My name is Albert Bonney and today we continue learning about our eye. The topic of discussion today is defects of the eye. That is, what are some of the problems that happen in our eye which will affect our vision. Very simple terms, why do we wear eyeglasses? Here is what I would like you to do. What are the difference between these two glasses that you see on the screen? There are two obvious differences, that is, the frames are different and the shape of the lens are also different. But other than that, are they same? Can both of these eyeglasses be used by the same person? Of course not. These two lenses are used by two people having two different eye defects. And the objective of today's class is for you to be able to talk to a person, ask them what are some of the problems that they are having in their eye, and for then you to tell them, hey, this is your problem and this is the lens that you can use. Very simply put, by the end of this class you will be eye doctors. Are you ready to be eye doctors? Then let's start. These are the four topics that we will talk about today: myopia, hypermetropia, presbyopia, and cataract. I know all these sounds very scary, but trust me, the only difficult part about these four defects are the name. What it is pretty easy. So let's first focus on myopia. These are the five topics that we will kind of cover in myopia. What is the common name of myopia? What is myopia? What happens in our eye for myopia to happen? And what is the effect of that? And finally, how do we solve this? So let's first look at what is the common name of myopia. It is nearsightedness. And the common name kind of gives away what myopia is. Nearsightedness, or you can see nearby objects but have difficulty seeing faraway objects. So once this is clear, now let's look at why is myopia happening, or what change happens in our eye for myopia to happen. A quick revision: normally, for you to be able to see something, the image of that object needs to be formed on the retina, not in front of the retina, not behind the retina, but on the retina. Okay, so with this information, let's look at what happens in a myopic eye. The image is formed in front of the retina. An obvious question you will ask now is, but sir, why? Why does it happen? And there are mainly two reasons this could happen. The first one, the curvature of the eye lens is increasing or it becomes more thick. The other problem is your eyeball is elongated and the image which used to be formed on the retina is forming in front of the retina. So effect is image formed in front of the retina. The most important question now, how do we solve this? What is the correction that we can use for this? The image here answers the question. We use a concave lens. A concave lens diverges the light ray. So by diverging the light ray, now the image which used to be formed on in front of the retina is finally being formed on the retina itself. So correction is concave lens. So this is what myopia is. The next topic that we'll focus now is hypermetropia. Easy way to remember hypermetropia is, it is the exact opposite of myopia. So everything you learned in myopia, do a opposite of it, you'll get hypermetropia. We will look at the same questions that we look for myopia itself. First, what is the alternate name or the common name? And it is far-sightedness. Ability to see faraway objects but difficulty in seeing nearby objects. And this name itself tells you what it is. What change happens in the eye? It is again the exact opposite of myopia. In myopia, the image was being formed in front of the retina, whereas in hypermetropia, the image is formed behind the retina. Why does it happen? Remember, opposite of myopia. In myopia, the eye lens was becoming thicker. Here, the eye lens is becoming thinner, or in other terms, the focal length is becoming too much. Or the second reason is your eyeball is becoming shorter. So the image which used to be formed on the retina is now forming in behind the retina. Effect, like I said, image formed in behind the retina. And how do we solve this? Final question. Think opposite of myopia. In myopia, we used a concave lens, and in hypermetropia, we are using a convex lens. So by using a convex lens, the image which used to be formed behind the retina will now form exactly on the retina. So now moving on to the next two defects, I have a small little brain break for you. Imagine I have a dog, and it's a cute little dog. You can see the picture here. Now this cute little dog of mine and me, both of us have a problem. Both of us are not able to see nearby objects. Now I have a lens that I use. So this is the lens that I use. Can I give my lens to my dog? By giving my lens to the dog, will it help my dog to see nearby objects? The answer for this question will be revealed by the end of this class. So stay tuned to get the answer. Now let's move on to the last two topics, that is presbyopia and cataract. We will look at both of these questions together because there is a common feature for both of them. What is the common feature? Both of them happens to older adults, not to young people, but only people who are above a certain age. You will be wondering, what is this disease? So, what is presbyopia? It is when the power of accommodation of eye reduces or decreases with age and the near point recedes away. Two terms that you learned in the last session: power of accommodation, the ability of your eye lens to change the focal length, now that reduces, and the near point, that is a point where you can see a nearby object, is kind of slowly going away. Now, what happens in cataract? Here, the vision becomes pretty cloudy, and because it becomes cloudy, you are not able to see, partially see, or like fully not able to see what is in front of you. What change happens in the eye? In presbyopia, the clue here is power of accommodation, right? For power of accommodation to happen, it is your ciliary muscles that need to be working. So if your ciliary muscles weaken, and muscles do weaken as you grow old, then your power of accommodation will slowly be affected. And this is what happens in presbyopia. The ciliary muscles weakens, and your power of accommodation is slowly receding. Whereas in cataract, the crystalline lens, as you become older, becomes milky and cloudy. And if you remember, crystalline lens is the lens that is inside our eye, and that becomes cloudy as we grow older. What is the correction for both of them? For presbyopia, and these are people who are having myopia and hypermetropia, they use a bifocal lens. Bi means two. So this will be a lens which will have concave lens in the upper part and convex lens in the lower part. For cataract, there are no lenses that you could use. You simply will have to go for a cataract surgery. So I hope you are clear with the four topics that we learned today. That is myopia, hypermetropia, presbyopia, and cataract. Here's a little tip for you to learn this. Learn myopia, put everything opposite of myopia, and you will get hypermetropia. Presbyopia and cataract, like I showed you in the note here, learn it together so that you will be able to compare and remember it much more easily. Now let's discuss the question that we were all waiting for. Can I give my lens to my dog? The answer to that is here. The picture on the left is how a human sees the world. Picture on the right is how a dog would see the world. There's a clear difference between both, right? Which on the left, you're able to see colors like red, green, yellow very, very clearly. And that's how we normally see the world. But whereas for a dog, it cannot pick up the light red, and it probably cannot pick up the light green also to the intensity that we do. This is because they do not possess some of the cells that we have in our eye that helps us see the red color. Even if I give my lens to my dog, it will not help them because their eyesight is very different with my eyesight. Now, if you are good science students, you will be wondering, is this how every other animal also sees? I would actually invite you to go Google and understand more of how every animal have a very different eye vision. By this, I conclude today's session. I hope now you will be able to talk to people and understand what their defect is and also prescribe them what they could do to solve it. Tune in to learn more about what are the other effects that happen in our eye in the next session. Till then, bye bye and see you.